Hello and welcome to Apologetics 101. I am your host, Brian, and thank you for joining me on here. And today we are talking about the heat problem, the so called heat problem, the one that is brought up by critics a lot. It's popularized by Erica on her channel on Gutsy Gibbon. The same heat problem. We're talking about that today, and I'm going to be introducing to a model concerning the heat problem. What is the heat problem? Basically, the claim is because there are several different types of heat sources, and these heat sources are delivering a tremendous amount of heat. And so the idea is that the amount of heat would not be able to get really fast enough before these apocalyptic types of results ends up happening. Like the oceans boiling or vaporizing or the crust melting, and all life on Earth not being able to be livable. They're no longer becoming habitable as a result of this much heat. And there are a lot of heat sources during the flood. We're going to get into that and talk about that. And so people have labeled this the heat problem. It's kind of a generic term for a lot of different heat sources. But what ends up happening is a lot of people that deal with these kinds of heat sources will deal with one or two heat sources while ignoring others, or they'll actually abandon other types of heat sources like accelerated nuclear decay or something of that nature. And I'm a big believer in accelerated nuclear decay. I think there's strong evidence supporting accelerated nuclear decay. We'll talk about that in a little bit, but or here in later in the video. And I do believe that it happened during the flood. And of course, that gives off an impossible amount of heat. So does other heat sources. And then when you combine them all, it's incredibly high. We're going to talk about that too. And you'll see how high the heat is during the flood. Probably higher than any, no, there's no probably to it. Definitely more heat generated during the flood than any other event in human history. So, and the issue is how do we get rid of that heat and how do we do it really quickly before those catastrophic results happen and before our life ceases to exist. And some people say, well, maybe it's a miracle, and then others say, no, maybe future physics. And then other people claim, oh, well, maybe you can't get rid of it naturally without invoking a miracle or future physics. And then and some people try to deal with it using naturalistic mechanisms, but they do so in such a way that they only deal with one or two heat sources, like maybe the heat generated during the CPT, catastrophic plate tectonics, the movement of the plates, or they try to deal with the heat generated from volcanic eruptions, or they try to deal with the heat from other sources. Usually, in most cases, accelerated nuclear decay gets ignored entirely, and in some cases, even abandoned. People abandon accelerated nuclear decay, or someone would abandon the CPT model, or something of that nature. And I never really liked how other heat problem solutions have been made, because a lot of times they will end up abandoning CPT, or they will end up abandoning accelerated nuclear decay, or they will end up trying to ignore heat sources, even heat sources that they will acknowledge happened during it, but they don't want to. They don't want to think about that, because then they have to calculate that in, and that's more heat they have to deal with, and that sort of thing. And so a lot of different proposals been made. None has really caught on, but I'm hoping this one will. I'm going to really be popularizing this model because I really like this model. It is perfect. It works very well, getting rid of the heat. The vast majority of the heat during the flood, over 99% of it, goes away before the end of the flood year. So I mean, this is really good. So, but we'll get to all that. We'll do some mathematical modeling. We'll talk about how it actually gets rid of all that heat. But anyway, without further ado, let's dive in. All right, and we will be doing a PowerPoint presentation today on the so-called heat problem. It's called the death of the heat problem, the geothermal feedback model, GTF model. That's the model that I'm going to be presenting in this presentation. And without further ado, let's dive in. All right, the death of the heat problem, the geothermal feedback GTF model. This is the model I'm going to be presenting in this presentation. Let's do this. All right. Now, during the flood, there are a number of heat sources. During the flood, there's accelerated nuclear decay. There's billion-fold acceleration of tectonic plates, according to the catastrophic plate tectonics model or CPT model. The fountains of the Great Deep also issue some heat because the further down you go, the hotter the water gets. If you get all the way to the mantle, it's pure steam. So if you got water coming up from the mantle, it's pure steam, or you got water coming up from the crust, it's going to be anywhere from warm to hot. So we're talking about additional heat added to the flood. And then we got volcanic heat. This is heat generated from volcanism. We're going to talk about that here in just a few minutes, actually. Every flood model includes volcanic eruptions happening on a global scale, and so including the CPT. And so volcanic heat is another heat source. Meteor impacts, that's another one. This one was also talked to me by Mike Ord, who was interviewed on my channel recently. And we talked about meteor impacts during the global flood. He gave some pretty good evidence that meteorites did strike during the global flood. Some critics will add other heat sources like limestone generation, which, by the way, I've actually checked with the math on my thing, not in this particular presentation, but I checked it after I already made this presentation. It doesn't really affect my model very much. It's very negligible, but some people might add other heat sources. It wouldn't really matter anyhow. This is a thermally driven model, as we're going to go into, and so the more heat you apply, the stronger it becomes, the more effective it becomes. But these are the main heat sources. So let's dive into each one in turn and see what we're looking at in terms of how much heat is being generated during the flood. Okay, accelerated nuclear decay is 1.68 times 10 to the 30th joules of heat. This is the number that is in Erica's main video on the so-called heat problem, and that's where I'm getting that number from. I used her maximum number. I think Dr. Andrew Snelling, according to her at least, I haven't really investigate what Dr. Snelling says in papers or articles or anything like that on the heat problem, but allegedly he offers a much less heat generation during the global flood. But she offers this as the maximum amount, claiming that this is the number she's taking, and so I said, oh well, I'm going to use the highest number that they're willing to give, and I want to see how effective my model is. So if the heat turns out to be less, that's great. If it turns out to be this much, it still works. So it works either way. A billion-fold acceleration of tectonic plates, and according to catastrophic plate tectonics model, CPT model, as already mentioned, 1.0 times 10 to 29 joules of heat. Actually, I originally wanted to address this as Baumgartner's actual number. I come to find out it's actually 10 to the 28th power. But when ChatGPT originally told me, it told me 10 to 28 to 10 to 29, like a general one, and I wanted to use the maximum amount of heat generated during this time, so I used the 10 to 29th power. But it turns out that's actually one order higher, but it actually still works with my model. I mean, it still effectively works with it. If it's less, which it is, then it just makes it better, because it's less heat, less burden on the cooling mechanisms in my model. But you apply one order more, and it's still effective. So I realize this is probably an order higher than where Baumgartner is, but that's only a good because that shows you the effectiveness of my model. All right, let's go further to Fountains of the Great Deep. 3.24 times 10 and 27 power joules of heat. I allowed ChatGPT to calculate the amount of heat for the Fountains of the Great Deep. Then we have volcanic heat. Remember, every flood model includes volcanic eruptions on a global scale, and this has been estimated to 10 to the 28th power joules of heat. And then you got meteor impacts. This one is calculated from Erica's video. I took this number directly from her main video, the same one I took accelerate nuclear decay, 4.47 times 10 to 28 power joules of heat, or 26 power joules of heat, and for meteor impacts. All right, the total heat produced during the global flood is 5.67 times 10 to the 30th power joules, which is actually higher than the one Eric could come up with. That might be because I've got one order higher here in the CPT, but it is higher than the total number that Erica had given. But this shows you the effectiveness of my model either way. So, but kind of imagine the true heat might be a little bit less than this, and that's fine. But either way, it works. But it is 5.67 times 10 to the 30th power joules, and that's an impossible amount of heat. You're going to see in a minute, comparing it to other heat sources, just how whopping big that number is. It's a huge, huge amount of heat. All right, the heat generated from accelerated nuclear decay, which I call AND, here abbreviated as AND, remains the largest contributor of heat during the global flood. I think that is universally accepted. Even with the evolutionists, they don't accept accelerated nuclear decay, but they will argue that because our position is accelerating decay and the nuclear decay accelerating as much as they think it is accelerating would generate more heat than any other heat source. And it does appear that way, that it is the largest generation of heat source during the flood is being generated by accelerating nuclear decay. So I understand why there's a lot of flood advocates that try to ignore or even abandon accelerated nuclear decay so they don't have to deal with the heat, because it does actually deal the most heat during the global flood. All right, just to kind of give you an idea here, you got the flood, the heat during the global flood, 5.67 times 10 to the 30th joules. And then you got the annual global energy consumption, 6 times 10 to the 20th power. Mount St. Helens eruption 1980, 1 times 10 to the 17th power. Hiroshima atomic bomb, 6.3 times 10 to 30th power. And so you got this, and look at this scale right here. And this is how big of the heat is generated. Now, keep in mind, this is the heat that's being generated during the flood year. So it's not something it's not like it's being generated all at once, in 2 seconds or anything like that. So it's being generated over time during the time of the flood year. But it's still a lot of heat, just the same. So I can understand why people might have that issue with the heat. When they look at that much heat, they say, "Oh, that's just so impossible," because it's a large amount of heat. But it's not impossible to get rid of. Not if you have the right mechanism that's going on during the case of the global flood. All right, there are certain assumptions that go into the heat problem. Okay, I identified 9 assumptions here. All of the heat needs to be dispelled in a single year. This is one that I realized early on that I even found myself making this assumption. I don't know why we think that all the heat has to go away in 1 year, but in reality, some of the heat can actually alleviate over time following the year safely without hurting life or anything like that. It can be mitigated over time using the same naturalistic processes that are in cooling components and things like that are used in my model that will follow the flood year. And so there's no reason for that not to be the case and be dispelled over time. And assumption number two, all of this heat being dumped into the oceans all at once. This is one I found them doing a lot. Erica does it a lot. Like, oh, well, if you take this much amount, it would boil the oceans, or you take this much amount, it would vaporize the oceans. The numbers are actually correct, what Erica says on the numbers. The problem, however, is that it assumes either one of two things. The one, it's assuming that it's being dumped all at once into the water and happening in 2 seconds. But all that heat is actually generated over the course of a year. So you have to assume it's being boiled or even vaporized by the end of the year. But then that assumes that there's no mechanism to alleviate the heat within that period of time. Assumption four, the Earth is a closed system. Critics acknowledge the fact that the Earth is an open system, that the heat isn't trapped here, that the Earth is open to space. Heat can actually irradiate out into space as infrared radiation. They acknowledge this, but they treat the Earth as if it's a closed system, as if all that heat is somehow trapped here. In reality, it's not trapped here. Another one they treat is like heat trapped in the crust, or that the conduction process cannot be bypassed. This is because conduction it happens very slowly over time. It's extremely slowly. For that much heat, at least the one that's generated with the CPT, it would literally take millions of years for all that heat to actually leave the crust. So either they will go and act like it's trapped in the crust where it can't leave at all, or that because of the slowness of the conduction process, that it would take millions of years to happen, which would be the case if you cannot bypass it. But you have to assume it can't be bypassed, and we're going to find out in today's video that it actually can be bypassed. And my model is going to show you how it actually can bypass conduction using a thing called convection, and we'll talk more about that later. Here's one. Assumption 6 says mantle convection currents has always moved at today's rate. Uniformitarian assumption. That's incorrect. Mantle convections can, and this is even according to modern physics, convection can actually speed up with more heat. So the more heat that's applied to convection, the faster it will be. And that's true of even in modern physics. We know that to be true. We'll go into all that, but convection does actually speed up. Here's assumption 7, laws of physics and natural processes cannot alleviate the heat. That's an assumption. Now this one's kind of a reasonable assumption because the physical processes do have physical limitations, and eventually they reach their physical limitations. But in the model I'm going to show you, because the components are working in concert with each other in a kind of a loop, and you'll see that in a second, it actually never reaches its physical limitations. It has them, it just doesn't reach them. And so, but the idea that that no component, naturalistic component, could be able to alleviate the heat is an assumption. It might be a reasonable one, given certain types of situations, but it's still an assumption. Okay, assumption 8. One must alleviate the heat only by either appealing to a miracle or future physics, the fallacy of false dilemma. This is the fallacy of false dilemma. Erica in her video seems to be trying to get out of it, trying to make you think it's optionally restricted. If something is optionally restricted, it would not be the fallacy of false dilemma, except this is not optionally restricted. There are ways. In fact, I'm actually going to introduce a way today that does not invoke miracle, nor does it invoke future physics. In fact, it works off of presently known physics, that what we actually know is true, and in fact, what we actually observe in the present. So this is going to be an interesting one. All right. There's just too much heat to handle an argument from incredulity. That one was delivered to me by a critic. He likes to argue from incredulity. But the fact that it's an impossible amount of heat, and it is an impossible amount of heat. There's a lot of heat involved. It really is. I'm not trying to water down that fact. There is a lot of heat that's involved, for sure. but the fact that it's a lot of heat doesn't mean it cannot be dealt with. So we can't just assume that just because it sounds unbelievable, based on our personal sensitivity of what sounds true and what doesn't, that we can't sit there and get rid of the heat. You have to be willing to listen to the model and see whether that would be able to get rid of all the heat. All right, let's start out with what is a feedback loop. Okay, we're going to be talking about feedback loops today, and it's going to be an essential part of this model. Okay, what is a feedback loop? An effect where an amount or level produced by a process, system, etc., increases or decreases the amount produced by the same process, system, etc., at a later time. Cambridge Dictionary feedback loop. Okay. In a scientific context, a feedback loop is a process where a system's output is used as input to modify its future behavior, either to maintain stability, negative feedback, or to amplify changes, positive feedback. Google AI. The path by which some of the output of a circuit, system, or device is returned to the input. Dictionary.com. Okay, I'm going to give you my definition. It's a system where the results are being fed back into the system to make further changes to the system as time moves forward. All right, there are two different kinds of feedback loops. There's a positive and there's a negative feedback loops. A positive feedback loop is defined as a process in which a change in a system. Positive feedback loop is a process in which a change in a system triggers a response that amplifies or reinforces that initial change, pushing the system further away from its original state. Negative feedback loop. A negative feedback loop is a process in which a change in a system triggers a response that counteracts or reduces that initial change, helping the system maintain stability or homeostasis. Examples of positive feedback loops: childbirth that releases a chemical that causes the retractions. The more retractions the woman has, the more her retractions increase. As fruits ripen, they release ethylene, which causes further ripening, which leads to further releases of ethylene, which causes an even greater increase in ripening, and so on and so forth. There are many examples of positive feedback loops. Another example would be a fever. As a fever gets hotter, our bodies sweat, but our sweating acts as a natural cooling mechanism for our bodies, which helps reduce our fever. The higher our fever gets, the more we sweat. I like this one because it doesn't actually include a cooling mechanism there too, showing you how cooling mechanisms can work within a positive feedback loop. And by the way, if you actually search biology, people that are interested in biology out there, including some of you evolutionists, some of you evolutionary biologists, and so forth, you can actually find a lot of feedback loops, both positive and negative, involving biology. So there's a lot of feedback loops there if you want more examples of that. Examples of negative feedback loops: the water cycle. This is a very famous example of a feedback loop in general, because most people learn about the water cycle in grade school, at least in the United States. I don't know about anywhere else, but in the United States, they learn about the water cycle during grade school. And it's a very popular idea that we understand. And I understood it pretty easily, the water cycle. But it's actually a feedback loop, and it's a specific type of feedback loop called negative feedback loop. And this is a perfect example of a well-known feedback loop, and it's a negative feedback loop. As water heats up, it evaporates. In turn, this evaporated water vapor condenses into clouds as it replenishes the lost water from the earth and returning the water it took via rainfall. Digestion of our food is another example. As we digest food, this causes an increase in nutrients and glucose levels in our bloodstream. And of course, our food is broken down as these nutrients are increased, and we get hungrier later on because our body needs more nutrients. And so the system starts all over again. But that's an example of a negative feedback loop. Okay, during the global flood, I mentioned this earlier, every flood model, including the CPT, claims volcanism during the global flood. This is going to be very obvious because there's a lot of tectonic activity happening during the flood. There's a lot of heat sources that we talked about earlier happening during the flood. And so all of these things, you know, you got the CPT going on, you got meteorite impacts, you got the fountains of the Great Deep bursting forth. All of that is going to create all kinds of big time big time tectonic activity, and in addition to that, you got earthquakes that are happening. That's also going to cause even further tectonic activities, and you also got a lot of heat sources. These are going to cause volcanic activity as well. In addition to that, the volcanic activity is going to cause positive feedback loops, as we're going to see in a minute, and this is going to result into more eruptions. And so you got all these different things that are happening during the flood that's going to be causing massive globalized volcanic eruptions to happen all over the planet, all the way from the beginning of the flood to the end of the flood, and even following the flood, volcanic activity will continue as a result. All right, let's move into this. All right, we're going to talk about the evidence for the volcanic activity during the flood. Now, I understand this video is not intended to try to prove the flood and that sort of thing. I think there's very strong evidence for the flood, and I presented that before. We talked about it in another video with Mike Ord. There's lots of good evidence for the flood. But the one thing that I will say is that this model will assume the global flood. Why will it assume the global flood? Because the heat problem itself has to assume the global flood. In order to keep the critics from arguing in a circle, they have to assume the global flood when they're arguing against the heat problem. And as a result, and the CPT itself also assumes the global flood as well. So I think it's perfectly reasonable for me to assume the global flood while presenting the model that actually shows how the heat is being alleviated during the global flood. In which case, that means I will interpret the rock strata in light of the global flood. In which case, there is evidence within the rock strata of volcanic activity happening during the global flood as a result. All right. Enormous rock layers, flood basalts. Example, Deccan traps, India, Siberia traps, Russian, Columbia River basalts, USA. These are massive layers of volcanic rock, some covering hundreds of thousands of square miles and thousands of feet thick. Conventional geology dates these to various points in deep time, but creation geologists interpret them as flood related due to rapid deposition, lack of significant erosion between flows. Flood model view these point to catastrophic volcanic episodes consistent with massive tectonic instability during the flood. All right, tectonic uplift and rift zones. During the flood, many models proposed that the Earth's crust was heavily fractured, e.g., due to runaway subduction or catastrophic plate motion. These tectonic movement would release enormous internal heat and pressure, resulting in widespread volcanism. Modern tectonic features mid-ocean ridges, deep subduction trenches, and uplifted mountain ranges reflect massive global restructuring. Implication, volcanism was not isolated but global as crustal plates shifted, collided, and cracked apart rapidly. Tuff layers and volcanic ash and sedimentary rocks. Fine volcanic ash layers, or tuff, are found throughout the geologic column, or so-called geologic column, often interpreted with fossil-rich flood sediments. Example, the Green River Formation, the Yellowstone area, and many layers of the western U.S., Europe, and Asia. Volcanic ash blankets cover large areas, indicating explosive eruptions on a continental or global scale. Significance: ash deposition on such a wide scale is better explained by large volcanic events, not the small eruptions we typically see today. Mass extinction events linked to volcanism. Mainstream science links mass extinction like the Permian and Cretaceous extinctions to massive volcanic events. Massive volcanic events. Creationists reinterpret these events as flood-related burial phases where volcanism contributed to rapid burial and ecological collapse. In the flood model, this suggests volcanism was a key mechanism in ecosystem destruction, burial, and fossilization during the global flood. Pillow lava and submarine volcanism. Pillow lavas, boveous lava formations that form underwater, are found in many geologic layers. Their widespread presence within the sedimentary layers indicate that volcanism was occurring underwater, consistent with rising levels during the flood. Evidence of lava erupting beneath the floodwaters showing that volcanism was happening even as sediments were being laid down. Global volcanic aerosols and climate impact. Volcanic eruptions release ash and sulfur aerosols into the stratosphere, which block sunlight and cause rapid cooling, a post-flood ice age mechanism. Evidence of volcanic aerosols and ice cores suggests large-scale volcanism just before and during the ice age, which means that this volcanic eruptions is occurring both during the flood and following the flood. This supports the idea that the flood era volcanism helped trigger rapid cooling post flood, fitting both geological and biblical timelines. Okay, here's a fact: volcanic eruptions can cause positive feedback loops to happen. In fact, positive feedback loops can really happen in just about any geological event. Earthquakes, for example, cause positive feedback loops. Earthquakes cause more tectonic activity, which causes more earthquakes and leads to more greater earthquakes happening and that sort of thing. So, and volcanic eruptions do the same thing. So, volcanic eruptions can cause positive feedback loops to happen. All right. Volcanic eruptions can create positive feedback loops. Mount St. Helens 1980 eruption. The massive eruption released tremendous pressure from magma chambers, causing further decompression, which in turn led to increased volcanic activity and heat release. This amplified releases of gases and pyroclastic materials, contributed to atmospheric cooling through aerosols and ash, while also triggering more explosive events due to reduced confining pressures. Once heat is added by explosive volcanism, the system responds with more volcanic activity, ash dispersion, and increased heat dissipation. It also shows the greater geologic movement triggered by pressure release results in more geological activity. Mount Kilauea, if that's the way to pronounce that, volcano in Hawaii, in Kilauea, I want to say Kilauea. Yeah, we'll say Kilauea. In Kilauea's frequent eruptions, lava outflows reduce pressure in magma chambers, encouraging further melting in the mantle due to decompression. As more lava is expelled, convection in the mantle becomes more vigorous, drawing in more magma and prolonged eruptions. This is classic thermal and mechanical feedback loop where increased magma movement results in even faster movement where plate acceleration and convection feed into each other. Additionally, heat from lava flows fuels high evaporation, tying into a cooling and energy dissipation system. Pittendy Fournaise, Reunion Island, one of the world's most active volcanoes. It's located on Reunion Island, a French overseas territory in the Indian Ocean, east of Madagascar. Pittendy Le Fournaise experiences frequent low viscosity eruptions as lava is expelled. Decompression encourages further mantle melting and eruption renewal. Additionally, flank movement from lava buildup affects magma chamber stability, inducing more eruptions. In this feedback loop, movement begets more movement, and heat leads to further melting and increased activity. This shows how internal dynamics reinforces themselves. Volcanologists observe that one eruption at Penton often increases the chances of another eruption shortly afterwards. This cyclical behavior is a textbook positive feedback loop where heat and pressure drive eruption, and eruption can't speak, facilitates more heat release, not less. Okay, Aska volcanic system, Iceland, and yes, that's pronounced Aska. Aska has a history of subsurface magma chamber collapse events where an eruption drains the chamber, reducing pressure and allowing more magma to ascend. The decompression feedback can lead to renewed eruptions. It also sits atop a rift zone where plate spreading encourages continual uplifting and volcanic renewal. Aska shows that when heat and tectonics interact, more heat can trigger more efficient mantle flow, leading to further eruptions. This reinforces the principle that tectonic and thermal systems amplify one another in a positive feedback loop, especially during periods of global instability, like in the case of the flood. All right, here's a positive feedback loop in Kailua 2018 eruptions. It shows you the way this positive feedback loop works. Yeah, heat sources, lava flow, cooling mechanisms, increased convection, and it just kind of goes on like that. I would probably start it here, increased convection, but magma rises more rapidly due to decreased density, mantle plume and magma chambers, extensive lava flows spread across lowlands, and then cooling mechanisms, lava contact with open oceans and atmosphere. Penton de la Fournaise, here's a positive feedback loop regarding that, as well as cooling mechanisms and that sort of thing. All right, so I've asked ChatGPT to do a analysis of all these different examples to see how closely related or similar they are to my model. There's several strong matches. There's a few there are partial matches and some there are weak matches. They're all positive feedback loops, but it just depends on what we're talking about here. I think Lake Fissure was the best match, was the strongest one that was almost identical. It might actually have been identical to the one that I'm proposing here. And so it was the highest matching. Now, critics, I can keep going in detail and give you example after example after example of positive feedback loops with volcanic activity and including with cooling mechanisms and that sort of thing. I can keep giving you examples of that, including ones that are very similar to mine. But there's got to be a point where you have to stop and say, maybe it's not the fact that you need more examples than the ones I've already provided. Maybe it's just because you really don't want to believe in it. So that may have a lot to do with why you reject it. But the examples I gave is enough to establish the fact that positive feedback loops like this actually do happen with volcanic eruptions. All right, now we're going to talk about the different approaches that people have had in terms of the way in which they approached this in the past. We're going to talk about the difference between an asymmetrical approach and a symmetrical approach. Okay, asymmetrical is, okay, imagine if you draw a straight line on the pavement, like concrete pavement. You're in a concrete floor room or whatever, and you drew a straight line all the way across. And I asked you to walk across that line. Would you ever reach the end of that line? Well, yeah, eventually you reach the end of it. But what if I drew it as a circle, and then I asked you to walk around the circle? Would you ever reach the end of the line? Well, no. And that is true with a lot of these mechanisms. Most of these solutions for it, I mean, with the exception of maybe Miracle, but with certain solutions that are being proposed are what I call asymmetrical approaches. And of course, in an asymmetrical approach, you will always reach the physical limitation. and that's a problem, right? That's the reason why a lot of these solutions will only try to resolve the heat from a given source, like CPT. It's also why most of them tend to ignore accelerated nuclear decay or abandon accelerated nuclear decay altogether, because it delivers the most heat, and so it's the most heat that you would have to deal with during the global flood, and so they tend to either ignore it or they just simply abandon it, abandon the idea, so that way they don't have to deal with the heat, and that sort of thing. And you're free to abandon whatever model you want to abandon, but their evidence is strong in favor of it. So why should you have to abandon it just because there's a lot of heat that we have to look into? That we shouldn't have to abandon it just because you have a lot of heat that has to be looked into. But it is true that if you're dealing with an asymmetrical approach, where you're having to deal with not in the form of a loop, but in the form of components, and that component eventually reaches its physical limitations. Water can only absorb so much heat, even with the floodwaters. It can only absorb so much heat before it's evaporates. Once it evaporates all the water, you can't get anything more out of it if all the water is evaporated. So eventually you always end up reaching these physical limitations. But with a positive feedback loop, you don't reach the physical limitations. They have physical limitations, don't get me wrong, but because this particular dynamic feedback loop that I'm going to be proposing works in concert with all the components of the feedback loop, including the cooling mechanisms, they work together to alleviate the heat as a result of the conditions of the flood. And as a result, you never actually reach the physical limitations. That's important. You never reach the physical limitations. They have them, but you never reach them because each of the components are working with each other to alleviate the heat. So, no physical limitations are reachable, okay, in a positive feedback loop. That's why you can, in some cases, you can even have runaway effects happening. That's why you can have, because the CPT that Dr. Baumgartner proposed is actually a runaway subduction effect, in which case it accelerates 1 billion times faster than it is normal. And that's within the lines of known physics. It can do that. It can have that kind of effect. That's a positive feedback loop. And it's a runaway. It has a runaway effect. Mine don't have a runaway effect, but a positive feedback loop can happen that way. And there's volcanic activity that's still going on because it's constantly feeding into itself, and that's why it keeps on having the volcanic activity. So you never actually reach the physical limitations when all of the components are working together to make it happen and feeding back into itself. All right, now we're going to be talking about the geothermal feedback model. That's the model that I proposed. Okay, the geothermal feedback model. Okay, as heat is generated through a variety of sources during the global flood, whether that is accelerated nuclear decay the billion-fold acceleration of tectonic plates as predicted and postulated by the catastrophic plate tectonics or CPT model, meteor impacts, the fountains of the Great Deep, volcanic heat, as well as any other heat sources that the critics might propose, once generated, cause increased mantle convection, which increases its effectiveness, efficiency, and speed. That's right. It actually gets faster the more heat you generate it, and it actually does get really, really fast. As we're going to see later, my model shows that the mantle convection would have moved at a speed that is about 1.7 billion times faster than current rates. And it's within the realm of known laws of physics. It can actually do that. Yes. Now, of course, they may assume uniformitarian assumptions and assume that the rate in which it's currently today in today's models may not be moving that fast. but it can, from the line of the laws of physics, it can actually move that fast, and we're going to talk about that later as well. But it is actually possible. It actually is within the laws of physics. All right. Proportionate to the amount of heat that is being generated, causing a significant amount of volcanic activity worldwide. Okay, this heat then is expelled via volcanic eruption. So the heat is being expelled out of the volcanic eruptions. And volcanic eruptions can expel the heat from the inside the earth. All that heat that's building up inside the earth is being expelled via volcanic eruptions on a global scale. This heat is either transported to the air or water or both, depending upon what stage of the flood we're in upon each eruption. This then distributes heat to the atmosphere and or via floodwaters. So it can either go in the air or in the water. Now, very early on in the flood, probably at the start of the flood, maybe some of the volcanic activity could actually occur on land, but I don't think that's going to. I think that's going to be short lived, so it's not going to be a whole lot of in terms of on land. So the vast majority of the time, like well over 99.9%, it's going to probably be more like in the water or in the atmosphere, or both, depending on which stage of the flood you're in. All right. That this heat is either transported in air, water, or both, depending upon what stage of the flood you're in. Like I said, and upon each eruption, then this then distributes heat to the atmosphere and or by floodwaters. All right, this causes different effects. Volcanic heat that is expelled into the floodwaters is absorbed by the floodwaters. Water has the highest specific heat capacity of any liquid on Earth at 4.184 joules per gram to increase by 1 degree Celsius. This means that it takes 4.184 joules of heat to heat up 1 gram of water to be increased by 1 degree Celsius. This also means that the total heat capacity is calculated from this number and scales by volume. Now, I had a critic that misunderstood me and thought that I was saying that the specific heat capacity itself changes as a result of the volume of water. That's not what I was saying. The total heat capacity is calculated from the specific heat capacity. And the total heat capacity does actually scale with the amount of water. So the more water it is, the higher the total heat capacity. So we would expect it to be able to absorb a lot of water, since the floodwaters contain vast amounts of water from the sky, ground, and oceans, thus making the total heat capacity insanely high. The water would then absorb this heat into it, at least over time. So we're not talking about all this heat for an entire year that's generated being dumped into the water at once, including heat that hasn't even generated yet. We're not talking about those kinds of things. We're talking about over time, in a year, it's absorbing this heat during that time. All right. As the water heats up, it evaporates, pulling heat from the air as well. The hotter water gets, the faster it evaporates. This is a known fact. This is all this stuff is going to be according to modern physics. However, as it evaporates, it removes latent heat. That's the heat that is absorbed into the water with it. The faster it evaporates, the more heat that is removed from it. As the water evaporates, this increases cloud covering, which increases the albedo effect. The albedo effect is the reflectivity of the sun against a given surface, in this case, cloud covering. All this is happening proportionate to the heat that is generated from the heat sources during the flood. Cloud covering, albedo increase, and latent heat removal via rapid evaporation are all cooling mechanisms in this model. The increased cloud covering also increases the rainfall. The faster it evaporates, the more it rains, and the faster rainfall happens, the faster it replenishes the floodwater. The volcanic eruptions also spray ash and aerosols, SO2, into the stratosphere, which causes volcanic cooling. This is happening on a global scale until the volcanoes are completely covered by water, probably in the late mid flood. Every volcanic eruptions show that this to be an observed fact, but a famous example of this happening in April of 1815 was with the Mount Tambora, a supervolcano in Indonesia, literally blew its top, destroying its summit. The summit is the mouth of the volcano, and sprayed ash and aerosols into the stratosphere, causing the now famous, quote, year without a summer, end quote, in 1816. This greatly affected climate conditions worldwide, by the way. Just from one supervolcano going off. Imagine all of them going off. But one supervolcano, it really radically changed the climate for the next couple years and cooled the planet off significantly in 1816. Volcanic eruptions are known to cause these types of cooling events and changes to the climate on a global scale. But these volcanoes during the global flood would be worldwide, catastrophic, and producing far more extreme conditions. The ash and aerosols via volcanic cooling increases the albedo effect and reflects the sun's light back into space, causing a significant cooling effect to happen. This is all happening at a global scale. A significant amount of heat in the atmosphere from these volcanic eruptions then escapes into our atmosphere, from our atmosphere and into space. The Earth is not a closed system. Remember that assumption where they treat the Earth like it's a closed system. So a significant amount of it escapes into space. As heat is generated and regenerated throughout the global flood, the cycle starts all over again, with each component scaling upwards, amplifying and increasing proportionately to the amount of heat added to the system. If you try to figure out a heat source, I had never thought of being, say, some kind of thermal vents or something, and you increase the heat load, say, by 10%. Everything in this model will increase by 10%. The model only becomes stronger and more effective the more heat you add to it. Adding more heat will not make the model weaker, but only stronger. So, in other words, the default reaction of the critics is to try to add more heat to the to the so-called heat problem during the flood. They fear more heat. That idea of doing that might have worked for them in the past. This particular model is thermally driven. The more heat you throw at it, the stronger it gets, the more effective it gets. It literally takes the heat and it uses that heat against itself. It's literally the best type of model you could possibly think. It's a perfect model. It's the most powerful model on the so-called heat problem, and it takes all of that heat that's being generated, that impossible amount of heat, and it uses it against itself. It only gets stronger and more effective. The mantle convections get faster. The mantle convections get more effective. More eruptions, more heat is being expelled from the volcanic eruptions. More heat is absorbed by the water. The faster the water evaporates, the faster it releases that heat. The faster, more it rains down. The more cloud covering increases. The more the albedo effect increases due to cloud covering and volcanic cooling. All these increase proportionate to the amount of heat, and they all scale accordingly. Okay, they all amplify, and they keep increasing this way. And so, adding more heat does not destroy this model. It doesn't make it weaker. It doesn't work as a default. Like automatically, this model must not be able to work if you just apply more heat. That might have worked for the critics in the past, but it will not work with this model. The more heat you apply to it, the stronger it gets, the more effective it gets, because the heat is being turned against itself internally. Because this is a thermally driven, dynamic, positive feedback loop that's working off of the conditions of the flood that shows that the conditions of the flood would have created this type of reaction. When I went to ask ChatGPT what is the how guaranteed this would happen, that all the situations happening during the flood, meteor impacts, tectonic activity, all the other heat sources, all stuff that's happening with volcanic eruptions, fountains of the Great Deep, all the stuff that's happening. It said, on a scale between 1 and I would say 1 or 10 or 1 or 12. I might have said 1 and 12. I said, or no, 1 and 10. I did 1 and 10. Yeah, 1 and 10. One being, or 0 and 10 actually. 0 being impossible, not going to happen, and 10 being a guarantee that it will happen. 9 being highly probable, but still a little bit of a doubt. And 7 to 8 probable, 5 or 6 improbable, or and 1, 2, 3, maybe 4. I don't remember, but being totally improbable. 0 being impossible. I even introduced 10 as a guaranteed, but I didn't honestly think it would choose 10. It chose 10. And I was so surprised by this. I asked it later on if it still would choose 10. And it said, yeah, it still stuck by that. It guaranteed that because of all the stuff that's going on during the flood, all the flood conditions, everything that's happening, definitely will happen, that this would create a positive feedback loop that would have included cooling mechanisms that would have alleviated the heat over time within the flood year. And the vast majority of that heat will be alleviated before the end of that flood year. We're going to look at that later too when we deal with mathematical modeling. All right, let's go further in the geothermal feedback model. All of the heat sources in this model are limited and not exponential, including all heat sources generated during the global flood and believed by all current YCs. So this feedback loop will not lead to a runaway greenhouse effect. Some might say that this will lead to a runaway effect. It won't, because the heat sources involved are not exponential, meaning that the heat sources will not continue generating heat. They have a actual limit to it. The fountains of the Great Deep go off at 150 days. The volcanic heat actually weakens over time. And eventually gets to a much less extreme state following the flood. Although still powerful eruptions are still going on, but probably nowhere near as intense as what happened during the flood. There's not as much tectonic activity going on. The CPTs even stopped well before then, and so you don't have all of these things happening, and so the heat sources evolve. Obviously, when the plates stop moving, or slows back down, it's not going to generate as much heat. The volcanic eruptions eventually weaken over time as well. So by the time you get to the end of the flood year, the only thing that's actually continuing is accelerated nuclear decay, which in my model, I will talk about accelerated nuclear decay in a little bit, but it tapers off toward the end of flood year. The volcanic eruptions will continue following the flood year, but at a much, much less extreme level. And so that will continue following the flood. And those are the only two that will actually even be left by toward the end of the flood, is because accelerated nuclear decay will taper off somewhere close to the end of the flood when the volcanic eruptions weaken. We'll get into that in a little bit. All right, the floodwaters also act as a massive carbon sink as well as heat sink, absorbing a tremendous amount of CO2 during the global flood, produced by volcanic eruptions, the albedo effect via ash and aerosols into the stratosphere via volcanic volcanism counteracts the runaway greenhouse effect associated with greenhouse gases like CO2 with water vapor, the cloud covering, as well would as well aid with that. And so here's what I'm saying here. all that CO2 that's being produced in volcanic eruptions, it's going to be absorbed by the floodwaters. In addition to that, you got the volcanic cooling effect, right? The aerosols and the ash that's being thrown into the stratosphere as a result of the volcanic eruptions, and it's going to block the sunlight. The sunlight will reflect away back into space, creating that cooling mechanism. But it's also going to counteract any runaway greenhouse effect as well, because I know that the water vapor is going to evaporate. Water vapor is a major greenhouse gas. So is CO2. CO2 is not as big as water vapor. Water vapor is the biggest major major greenhouse gas. CO2 is not the major greenhouse gas. But both of these are going to be present, but the sunlight reflecting back out into space will counteract any runaway greenhouse effect as a result. And cloud covering will also aid with that as well. Most of the heat is alleviated by the end of the flood year. The positive feedback loop continues following the global flood, although not as intense as during the global flood. I already mentioned that, but each one of these components are heightened still above normal, even following the flood. The remaining heat following the flood, post-flood, is regulated and mitigated over time through these various processes: volcanism, convection, effectiveness, increased cooling mechanisms, etc., in addition to ice accumulation due to post-flood ice age, and is likely to be completely gone from the Earth's heat budget within a few hundred years following the flood. Now that's pushing the numbers as far back. I did do a mathematical test, which is going to be in here. I've done several, but this one's the most precise one based on my model. So I don't really estimate that it would be very long. I think it was like 5 or 10 years that was estimated. But I'm pushing, the only reason, but in earlier tests, I did push the numbers all the way up to a few hundred years following the flood. This was so that I can give the maximum possibility, the worst case scenario of how long it would take for all the heat to be alleviated in case there's more left over. You know how critics are; they will try to add more heat to the model and try to overwhelm it with the heat, the amount of heat. But it doesn't overwhelm it; it actually makes it stronger. Now, the most accurate test, the most precise test, is the one that I'm going to do show you that I did during the end of this presentation, where I will show you that it actually only took about an estimated. It is still estimated, but it's like 5 or 10 years. And I think that's probably going to be more realistic. All right, I've done the math on this model, and in every test, most of the heat is alleviated during the flood year, with the remaining heat safely mitigated over time. The values may differ depending on how much heat you are throwing in, but it'll always come out the same because the main focus of this model is on the mechanics of this model. Which always works. The only thing that might change is the remaining heat post-flood and the exact time that the remaining heat is alleviated. The math works in each test I ran on this. As more heat is added, each component increases proportionate to the amount of heat that is increased and added to the system. Most of the heat is alleviated during the flood year, while the remaining heat is distributed and mitigated safely over time post-flood. Setting it all on a positive feedback loop makes the heat go away. All of the heat generated during the global flood. I know that sounds hard to believe for critics that have just built their entire reputation on the idea that there was a heat problem during the flood, but this model actually does make all of the heat generated during the global flood not just a single heat source, and it does so without invoking any miracles to do it. It makes it go away. This is my silver bullet model because it resolves every heat source. It resolves the quote unquote the heat problem during the global flood. It removes the heat fast enough from the mantle and the crust via volcanic eruptions and distributes and disperses the heat through various cooling mechanisms, all via a positive feedback loop, which increases as the heat increases proportionally to the heat generated during the flood. This positive feedback loop will continue following the flood, but at a much more less intense rate. Okay, here's a graphic of the geothermal feedback model. You got the limited increasing of heat sources, increased mantle convection, increased cooling mechanisms. You got all the different cooling mechanisms: volcanic cooling, cloud cooling, albedo effects, rapid evaporation, etc. And of course, a removal of the heat. And then, of course, you got more heat just generated from these other heat sources, and as it goes, and it just kind of in a positive feedback loop, it actually alleviates over time. And of course, cooling mechanisms can be included in a positive feedback loop. And given the conditions of the flood and all the heat that's being generated, this would actually happen. Okay, geothermal feedback model. Again, another graphic showing you the positive feedback loop. Then here's one for Lake Fissure that I drew up or got drawn up. It's increased volcanic heat, rapid evaporation, increased cloud covering, increased aerosols. These are all, Lake Fissure is very exact toward my model. Similarities to the GTF model, increased volcanic heat, rapid evaporation, etc. Okay. You got geothermal feedback model again, another graphic showing the positive feedback loop. All right, Erica had produced this video on the so-called heat problem. I was going to actually show some clips from it, but I decided, well, I might do a review of the video later. But I did include some slides here responding to certain things that she does say in the video, and we'll just kind of do that. This video is already going to be long enough without making it longer by actually responding to Erica in the video, but we can kind of just move forward from there, and because I don't want this video to be longer than it needs to be. And plus, I do actually deal with certain things that she says in the video in the slides. And maybe I'll do a review of the video that she has there later. Alright, let's talk about Erica's mistakes in her video here. Implied straw man argument. No YSEs today claims that accelerated nuclear decay occurs from creation to the flood. She estimated time from creation to the flood, and she estimated time from the flood to time of Jesus, or from creation to the time of Jesus, whichever it was. And if a YSE proponent claims accelerated nuclear decay at creation, they do so within the bounds of the creation week, when God is speaking things into existence, or during a single event like the fall, where the physical universe has been changed and corrupted because of sin, Genesis 3 and Romans 8, or during the flood year. Erica admits in her video this is not our position, but then why convey it that way? I don't understand why she even brought it up if she knows that's not what we argue. She assumes that all of this heat was dumped into the water all at once. We've already talked about that, such as boiling and vaporizing the oceans. However, these numbers concerning the heat sources that represent an entire event, like meteor impacts and catastrophic plate tectonics model, or in some cases, like accelerated nuclear decay, which is spread throughout the entire flood year. So, in other words, it's over time. It's not something that's happening all at once, and then all that heat is just kind of dumped into the water at the same time, all at once, without any way of alleviating it, and just happening right then and there. It's even apparently generating heat that hasn't even generated yet. So, because the heat is actually taking place over the course of that time of the flood year. She's assuming no mechanism for alleviating the heat in that period of time. We talked about this assumption. She is assuming that of and the actual issue is really the heat plus the amount of time to alleviate the heat. If you can withdraw the heat fast enough from the Earth's crust and mantle, and from the oceans fast enough, there's no real problem. My GTF model does this. The amount of heat isn't the real problem. It's really the amount of heat plus the amount of time to remove the heat. So the heat is only an issue if it cannot be alleviated fast enough. Baumgartner's email to me after hearing my model explained to him. I explained my model to him in email. He says, I appreciate all the time and effort you investigated in your email. Yes, essentially, all the mechanisms you mentioned are valid. However, the really difficult problem is getting the heat out of the rock quickly. Rock is an insulator, and the heat diffused through it very slowly. The rate at which it diffuses is controlled by the material property known as the thermal conductivity, expressed in terms of watts slash MK. In reference to the flood, the problem is how to cool a slab of hot rock with a temperature profile with respect to depth resembling what exists today beneath a mid-ocean ridge to resemble what exists today beneath the ocean floor. Okay, beneath the ocean floor, say 1,000 kilometers away from the spreading ridge, the equation for the diffusion of heat in rock using the well-established value for rock thermal conductivity says that about 63 million years are needed to cool an 80-kilometer thick slab of ocean floor to current estimate temperature. This is referring to conduction. That is the crucial issue, one that is much more difficult than the one you discussed, namely of disposal of the heat after it is deposited into the oceans. He is correct on all this other stuff that he says about conduction. However, what if you could bypass conduction? That's the interesting thing. We'll see that in a second. But he's right on everything he says here. But let's respond to this real quick. While Dr. Baumgartner is right that conduction through rock is extremely slow, the GTF model bypasses the bottleneck by invoking active geologic mechanisms like mantle convection, melting, and volcanism that vastly accelerates heat transport. Rather than relying on diffusion to cool solid slabs over millions of years, the GTF model demonstrates that those slabs are broken up, circulated, and even erupted into the oceans and atmosphere via volcanic eruptions on a global scale. The system acts like an engineered thermal loop where heat input drives mechanisms that accelerate heat output, while Dr. Baumgartner brightly points out that conduction is too slow to cool slabs of rock in post-flood timeframes. The GTF model is fundamentally different in that it doesn't rely on positive or passive conduction. It actively induces partial melting in the upper mantle and crust, facilitating heat transport via buoyant magma. The excess heat also lowers the viscosity of the crust and mantle, which increases the rate of convection currents. The latent heat is transported upward and released explosively during volcanism, a mechanism that operates orders of magnitude faster than conduction. This built-in melting and release cycle is a core feature of the model's ability to offload thermal energy effectively during the flood. My modeling here shows this approach can remove over 99.8% of the generated heat during the flood year alone. Strong evidence that the system's active processes effectively overcome the conduction bottleneck that Baumgartner is highlighting. So, in other words, I'm not saying that Baumgartner's wrong because he's not. He's 100% correct. What I am saying is that the slow process of conduction is actually bypassed as a result of my model, because when the mantle convection is heated up, it's heated up so high that it literally pulls the heat from the crust and the mantle, and it expels it through volcanic activity. at rate orders of magnitude much higher than what can be done through conduction. And so it actually bypasses conduction. And I've checked on this several times. It is absolutely true. Conduction can be bypassed through convection. And when it comes to the heat flow in the interior of the Earth, convection dominates. Conduction doesn't dominate. And I actually found examples of this as well, where I don't know if I added it to this presentation or not, but I did actually find examples of this where the conduction was bypassed as a result of convection, and where conduction is way too slow to explain certain phenomena that happen in the present. So we actually know that conduction can be bypassed via the convection if enough heat is being generated, because the more heat is generated, the faster convection moves. All right, let's compare analogies here. Let's do some comparative analogy. Conduction at normal rates is like heating a frozen turkey with a candle. It takes forever because the heat moves slowly through solid meat. GTF's use of volcanic eruptions to dispel the heat is like putting that turkey in a pressure cooker with jets and convection currents. You're rapidly cycling heat through it, turning part of it into liquid and pushing it out. Imagine jets on a jacuzzi. As more heat is added, the convection currents increase, pushing the heat upwards that are within the mantle and the crust more effectively and far more faster. Okay, Erica's claim about too much heat and hydrogen bombs worth of energy during the flood. She made claims like oh, well, this is so much heat, hydrogen bombs during the flood. Whenever you calculate heat up over time, you can actually calculate this kind of thing. But the Earth is able to handle a tremendous amount of heat. Okay, what if I threw out in a possibly high number, like let's say this number right here, which is 5 sextillion, 476 quintillion, 803 quadrillion, 699 trillion, 416 billion, 398 million joules of heat. That's a lot of heat. That's an impossibly high number. This is an impossibly insane amount of heat. 1 sextillion is 1 followed by 21 zeros. This number is unthinkable. This is equivalent to 26 billion and 179 million 750 26 million and 179,750 50 megaton Tsar Bomba. That's the most powerful I think they're hydrogen bombs, but that's ever been detonated. Yeah, it's hydrogen bombs that's ever been detonated. However, what if I also told you that this was the Earth's heat budget every year according to ChatGPT? That's right. And most of it comes from the sun. Like over 99% of the Earth's heat budget comes from the sun. What if I calculated over 100 years? The number comes to 547 septillion, 680 sextillion, 369 quintillion, 941 quadrillion, 639 trillion, 800 billion joules. This makes looks like over 2.6 billion 50 megaton Tsar Bomba explosions. The problem with Erica's assumption involving her calculating it this way is to imply that such an incredible amount of energy cannot be overcome, when in fact it can be overcome if there is a mechanism that can dispel the heat, and do so fast enough to avoid these cataclysmic results. Her argument is implying circular reasoning here, since she's assuming no mechanism for doing that very thing when in fact one does exist, or at least it does now because of the GDF model. A common argument made with the heat problem, especially by Erica, is that if a mechanism isn't known, then it doesn't exist. However, this is false. A mechanism could exist even if we don't know about it. Since YECs were previously unaware of this mechanism, and many organizations like AFG and CMI often admit ignorance of this mechanism, Erica had pounced on that to argue that one must not exist and assume that these organizations were denying such mechanisms. But this is false. This is an argument from ignorance. Not knowing what the mechanism is doesn't mean that it doesn't exist. This argument is flawed. However, now we know that this mechanism was, and it was a positive feedback loop generated by the conditions of the global flood, whereby the heat is dispelled by volcanic activity and the planet is cooled off by various cooling mechanisms, all working to alleviate the heat during the global flood at a significant rate. Okay, now we're going to talk about accelerated nuclear decay. I actually have my own theory on accelerated nuclear decay. We're going to get into that here in a little bit. Okay, this is the largest heat source during the global flood by the YFC positions, as agreed to both sides. Most YCs do hold to accelerated nuclear decay, by the way. Erica mentions that in her videos before, and she's right on that, most YCs do hold to it. Not all YCs hold to it. There are some that do abandon that idea. Like I said, that some will abandon it just so that they don't have to deal with that amount of heat and that sort of thing, which I can understand why they would do that, but if there's strong evidence in favor of accelerated nuclear decay, why abandon it just because critics have a problem with the heat? I'm still going to look into it and see if there's a way to resolve the issue, and there is. All right, the rate says the largest heat source during the flood, disagreed by both sides. The rate group inferred this conclusion from a number of evidences. Okay, they said that there's helium retention inside zircon crystals that shows 6,000 years of helium inside zircon crystals, even though helium is given off as a byproduct of nuclear decay. Even though uranium-238 has a half-life of 4.5 billion years, decays really slowly at today's rate and should be gone if it really is billions of years old. Likely current dating methods using this isotope. Helium is a slippery, quote, end quote, slippery substance and would have quote, end quote, slipped out if billions of years old, especially if it was heated up. The presence of fission tracks and polonium halos in the rocks indicates the rocks cannot had formed over billions of years, since these isotopes concerning the later only have half-lives of half a minute to 3 minutes long. C14 presence in the things supposedly dated to millions and billions of years old. C14 can't last for billions of years, since its half-life is only 5,730 years. After 90,000 years, there should be no measurable amounts of C14 left in diamonds or anything that is supposedly millions and billions of years old. But C14 has been found in coal, oil, dinosaur fossils, and even diamonds. It's been found in a lot of stuff. I just gave a handful of examples there. Discordant dates from radiometric dating. These have been discovered in isochron dating methods, in which they discovered false isochrons. Radiometric dating methods more than not disagree with one another. If accelerated nuclear decay had occurred in the past, then this would be one of the reasons why we have discordant dates from various radiometric dating methods. It would make sense to have dating methods that disagree with each other if you got different nuclear or different radiometric elements that are accelerating at different rates during the global flood. All right, known rocks often yield dates different from the actual known ages of rocks, such as volcanic rocks, samples taken from various volcanic eruptions. Not only do they show ages, quote unquote ages, that were hundreds of thousands to millions and billions of years old apart from the actual known ages, but applying different radiometric methods to the same rock simply yielded discordant dates as well. The often cited ad hoc explanation that these were quote unquote, too young to date take scientific support or lacks scientific support and justification, commonly deals with arbitrary numbers for what would qualify as quote unquote old enough, is self refuting by the fact that not only do secular scientists use these dating methods on rocks of that age, such as Mount Vesuvius in 1879, but evolutionists and OECs continue to use dating methods about Vesuvius against us, leading to the fact that they are being inconsistent. And finally, this argument is circular since they much assume all must assume. I think I said much. It's supposed to be must assume all rocks that they date as is old enough to date with radiometric dating. They have to assume that all other rocks are old enough by this argument. How do they know that? They can't know that if they just kind of just assume that all the rocks that they are dating with it are old enough. This provides us with strong scientific evidence support for accelerated nuclear decay. All right. Now we've established that there's evidence for accelerated nuclear decay. Let's talk about the decay rate of nuclear decay isn't constant. That's something that a lot of, I've had lots of debates on this by critics. Imagine there are going to be several that's going to try to debate me again on this subject matter. But I'm sorry, but we actually know that the decay rate of nuclear decay is not constant. It can be affected by certain conditions. We know that decay rates of nuclear decay isn't constant, that it's dependent upon certain conditions. At one time, scientists thought that nuclear decay decayed apart from external conditions, but they found out this wasn't true. This is why scientists came up with what became known as the decay constant, symbolized as lambda. I know Greek too, on top of that. I can't think of the name of the letter. I think it's lambda. However, this is not a true constant. It can be affected by certain external conditions, such as ionization, high temperatures, cold or hot, and pressure. These are natural conditions which can affect it. So these are our conditions in the natural world that we know that can actually affect accelerated nuclear decay. I've got critics that try to say, and I think that they might have gotten this from Erica, because I actually heard Erica say this as well, that that this doesn't occur naturally. That's false. Ionization happens naturally. Pressure and heat happens naturally. It doesn't require conditions of a star, like sometimes there's argued. We'll get into that in a little bit. But these are natural conditions that can affect it. The decay constant is the rate in which the nuclear decay happens today, and deep time proponents simply assume that this is true for all time. However, this is a philosophical assumption based upon one's uniformitarian beliefs. Laboratory studies and experiments have demonstrated that certain external conditions can and do affect these nuclear decay rates. We know these decay rates are not constant. All right, I'm going to give you some quotes from that as well. Laboratory studies and experiments on accelerated nuclear decay. We're going to start with ionization. Okay, we observe the bound state beta decay of fully ionized 187 iridium nuclei circulating in a storage ring with two independent methods, the time-dependent growth of hydrogen-like 187 osmium atoms, which has been measured in a half-life of 32.9 plus or minus 2.0 years. For bare 187 iridium nuclei could be determined to be prepared with 42 billion years for neutral 187 iridium atoms, with the results log feet value of 7.87 plus or minus 0.03. The half-life of 187 iridium atoms in any ionization state can be calculated. Thus, one can correct the 187 iridium 100 to 100, or excuse me, iridium 187, osmium 187 galactic chronometer calibration by taking account of the decay enhancements in stellar interiors, which will lead to more accurate estimates of galactic age. This is also cited by the RATE team as well. So basically, to break it down, they got something with a half-life, rhenium-187, that has a half-life of 42 billion years, and it literally jumped when they ionized all the atoms in it. It jumped to 32.9 plus or minus 2.0 years. According to Erica in one of her videos, I think the one that I've been talking about on the heat problem video that she made, try to claim that this is only done in stars or or in stars, conditions with star. That's false. That misrepresents the paper. This can happen in any kind of environment where ionization actually occurs. The idea ionization actually occurs in nature. Lightning bolt, for example, will ionize the atoms out of the air. And as we're going to talk about in a little bit, so does volcanic eruptions. Volcanic eruptions also ionize atoms out of the air. And so we'll see that ionization does actually happen naturally, as well as heat and pressure. So it doesn't require conditions of a star, and that was not the point of the paper. That they did talk about, they were looking into, because ionization does occur inside stars, and so that's what they were looking into, but it doesn't require a condition of a star. If you think it requires a condition of a star, then you misrepresented the paper, because that's not what the paper actually said. It actually is agreeing that this can actually accelerate when ionization happens, when the atoms themselves are stripped of their electrons. Okay, and of course, laboratory studies on accelerated nuclear decay, Erica's criticisms to ionization experiments, ChatGPT responses. This is what ChatGPT responds to Erica's claim there. Did the botch, because the paper is by Botch et al. That's how I was pronouncing it, Botch. So I like to say Erica botched up this paper because because botch is play on words, whatever. But anyway, she botches it up. Did the Botch 1996 paper require a stellar plasma to demonstrate ionization-induced nuclear decay acceleration? No, it did not. The Botch et al. 1996 paper and similar ionization studies involved fully ionized atoms in a controlled laboratory setting, not a stellar plasma. The key point of Botch's experiment and what made it significant was that ionization alone was enough to dramatically increase decay rates of certain isotopes like rhenium-187, and this happened under laboratory conditions using particle accelerators and or on traps, not inside stars. Here's what critics get wrong. Critics often try to argue these results only apply in cellular cores or extreme physical environments, not on Earth. But that's not what the study showed. The experiments did not simulate a star. It did not require extreme stellar pressure or fusion plasma. Simply removed electrons, ionization, and measured changes in decay rates and under known physics. In fact, some isotopes stop decaying entirely when fully ionized, e.g. certain beta decays, while others sped up dramatically, sometimes by 10 to the 6th power times or more. Okay, here's another reference here. Botch, or not reference, but okay, here Botch 1996 paper didn't require a star. It required ionization, which is something we can observe and produce on Earth. My model doesn't invoke stellar conditions. It invokes extreme but natural Earth processes like massive volcanism, gamma radiation, and pressure, all of which can generate high ionization levels across large volumes of rock. The lab experiments show that when atoms are stripped of electrons, their nuclear stability can change dramatically, and my model proposes conditions where that exact thing happens on a planetary scale. Okay, let's do with another quote for ionization. Bound state beta decay was observed for the first time by storing bare diasporium 163 ions in a heavy ion storage ring from the number of helium 163 daughter ions measured as a function of the storage time, a half-life of 47 plus 5 subtract 5d was derived by comparing this result with reported half-lives for electron capture, EC, from M1 and M2 shells of neutral helium 163, bounds for both the QEC value of neutral helium 163 and for the electron neutron neutrino mass or set. What does that mean? It means that it actually increased decay rates by all the way to the point of 47 days as a result of ionization. So, and that's increasing the helium. All right. Here's one on heat. On the basis of improved levels scheme of lutetium 176, it is demonstrated that the stellar S process production, as well as the stellar beta decay rate of that nucleus, depends strongly on temperature. This behavior results from the completely different half-lives of the ground state and the isomer. Since these states are coupled by induced transitions in the hot stellar photon bath, the effective half-life of lutetium 176 is drastically reduced. The 5 negative state at 838.64 keV was identified as the most effective mediating level. Consequently, lutetium 176 can no longer be considered as a chronometer for the age of the S process. Instead, it can be interpreted as an S process thermometer yielding a temperature range between 2.4 by 108 to 3.6 by 108 Kelvin. So that shows a paper that shows heat can actually affect nuclear decay rates as well. Here's one on pressure. Using state-of-the-art ab initio computations, we find that pressure and chemical environments have a small effect on electron capture components of the decay constants of isotopes. Beryllium 7 and Na22 and potassium 40. As expected, beryllium 7 shows the greatest amount of change with 0.1 to 0.2% increase as the decay constant at 25 GPa. GPa stands for gigapascals. And so at 25 gigapascals, it increased by a little bit, which is expected because of the amount of GPa that was increased by. Obviously, the greater the pressure, the more larger the change, the effect. As a metal, chloride or oxide, in their metallic forms, Na22 and potassium 40 shows an increase of 0.06% and 0.025% change, respectively, at 25 GPa. Upon further compression, potassium and sodium undergo an S to D electron transition of their valence electron, causing a significant change in the change density at the nucleus. Our results suggest that the effect of pressure and chemistry on potassium 40, combined with the opposing effect of high temperatures, will have little discernible effect on the heat production in the deep Earth, as our predicted changes are smaller than the uncertainties in the total decay constant for potassium 40. So essentially, it will have a very small effect when it comes to very little pressure, but if you increase the pressure, this will actually increase the decay rate If the more pressure it is, logically, the more it's going to increase. So it would just depend on the amount of pressure. But it does show that pressure can, in fact, affect decay rates. Okay, the GTLF model is my silver bullet argument since it resolves all the so-called heat problem in one shot. It makes perfect sense since that if I'm going to have a silver bullet model or argument, that I would also have a gun to shoot it with. It's by this that I introduced the RIFL theory to accelerate nuclear decay. RIFL stands for, and it is pronounced RIFL, it's RIFL, it's an acronym, it's pronounced RIFL, is an acronym that stands for Radio-Isotopic Feedback Loop. It is my theory to accelerate nuclear decay. It presents the first ever naturalistic trigger to accelerate nuclear decay. It is triggered by heavy volcanism, which in turn was triggered by the fountains of the Great Deep. Like the GTF model, it's set up on a positive feedback loop. Each burst of acceleration is accompanied by another burst of heat, and it is triggered an even greater acceleration upon each time the conditions by which nuclear acceleration can occur is fed back into the loop. Volcanism is known for causing ionization, and so does high energy radiation like gamma rays and X-rays. God enacts the fountains of the Great Deep, and these trigger ionization of radioisotopes. In the experiments I had presented to you, ionization showed to cause the greatest increase. As radioisotopes increase, they give off heat as a byproduct of radioactive decay. Heat is one of the conditions we know can accelerate nuclear decay. This initial burst of ionization would have created significant heat and thus further acceleration in isotopes that have already accelerated and initial acceleration in those that had not yet accelerated. Additionally, the volcanic heat and the heat from the accelerated subduction plates would have added to the acceleration as well. Heat can also cause pressure to build. The extra heat from the previous bursts of acceleration will have increased pressure in localized areas across the world. Additionally, volcanism and earthquakes happening would also create pressure buildup around the world. The accelerated subduction plates would have added to the seismic activity. This would have built up far more pressure in the interior of the Earth. The pressure close to the interior of the Earth right now is 260 GPa or gigapascals toward the core of the Earth, and even little pressure, according to the earlier paper, can accelerate nuclear decay by a little bit, 25 GPa at most. And so, logically speaking, more pressure can accelerate it even further. During the global flood, the interior of the Earth would have experienced more pressure than has ever been before or thereafter. Considering all the heat, all the tectonic activity, all the the fountains of the Great Deep, all the volcanic activities going on, all the breaking apart it's doing, it's going to exhibit far more pressure in the interior of the Earth than it's ever done in the past. We know from these peer-reviewed studies that pressure is one of the conditions that could affect nuclear decay rates. And continues, it causes further high energy radiation to be emitted, causing further ionization and nuclear acceleration, because ionization can also be caused by high amounts of radiation, like gamma rays, for example, because there are lots of energy in them. As ionization, heat, and pressure continues accelerating nuclear decay, the results of this are fed back into the positive feedback loop to cause further acceleration of nuclear decay, of acceleration and more heat to be fed back into the system. The more the conditions are fed back into the system, the greater the acceleration. When the acceleration happens, it causes more conditions that's fed back into the system. But this does not last forever. It is tied with the pressure buildup, the volcanic eruptions, and the fountains of Great Deep actually cut off after 150 days into the flood, and less than 5 months into the flood. And so, following this, the volcanism would have died down intense once the energy of the global flood becomes too low bit by the end of the flood. This would not have enough energy to sustain itself, at least on a global level. And so the positive feedback loop would have weakened and eventually tapered off toward the end of the flood. So, like I said, after 150 days, God closed the fountains of the Great Deep, closing the fountains of the Great Deep and diminishing the other heat sources, especially like the cooling mechanism of the GTF model slows down the volcanic activity following the 150 days of the flood, and the accelerated nuclear decay slows down with much less ionization, heat, and pressure. The feedback loop begins to lose strength. During this time, electrons are added to the atoms that are lost due to ionization, and they are neutralized, quote unquote, neutralized by electron transfer and chemical reactions, deionizing many of the ions created via ionization. This further slows the accelerated nuclear decay process down as less and less radiation is emitted. This slows down ionization as well. As accelerated nuclear decay reduces, so does the heat and pressure with each burst. With the slower volcanic activity, the feedback loop loses strength. No more, I'm talking about the positive feedback loop with accelerated nuclear decay. No more ionization, and very little heat and pressure is contributing to it now. It's still accelerating, but the increases are marginal at this point. The accelerated nuclear decay tapers off toward the end of the flood year when the volcanic activity that triggered and gave accelerated nuclear decay life weakens and slows down. Since and is done in bursts of acceleration and heat, the RIFL theory makes the heat generated by accelerated nuclear decay more manageable by the GTF positive feedback loop, which does continue beyond the flood year. Talking about the positive feedback loop associated with the GTF model. It continues following the flood year, but the accelerated nuclear decay actually tapers off toward the end of the flood year. The reason the positive feedback loop of the GTF model continues beyond the flood year is because volcanic activity continues beyond the flood year. The reason is that and does not is because the volcanism triggers and via ionization. But when the volcanic activity slowed the energy required for ionization, thus the positive feedback loop for accelerated decay tapers off, but the positive feedback loop for the GTF model continues beyond the flood year, although this too continues at a much weakened state. Okay, here's a good graphic of that, how that looks, ionization, accelerated decay, heat, pressure, and you got the experimental evidence over there for these conditions affecting accelerated nuclear decay. Here's another one that shows, another graphic that shows this. Accelerated nuclear decay and ionization, high energy radiation. The ChatGPT didn't make a mistake on the graphic here. The high energy radiation is really connected to the ionization, not pressure. But maybe it's connecting it to the pressure because the pressure would cause more accelerated nuclear decay, which would create high energy radiation at that point. But the high energy radiation would cause ionization. All right, now we're at the part of my model which I'm going to do some mathematical modeling. Math is not my strong suit. I didn't do any of the math here. This was all done automatically by AI program called ChatGPT. I allowed ChatGPT to do 100% of the math on this, and it actually does a very good job. There's a lot of complicated math that's involved, but it actually does a very precise job of showing how this model mechanically effectively works in alleviating the heat during the flood year and post-flood. All right, the table for the total heat sources, we talked about that at the beginning of the video. You know, I got accelerated nuclear decay. I told you I got the accelerated nuclear decay from Erica's video, as well as meteor impacts from Erica's video. The entire flood year, the first 12 months, will have the accelerated nuclear decay. And the meteor impacts probably from early in the flood, from various meteor impacts during the flood, but not like, as much as spread over as much as accelerated nucleus. Catastrophic plate tectonic CPT, again, Baumgartner's model. Yes, I know it's one order higher than his, but that just shows you how effective this model is. It just means the heat's actually going to be less than that. Entire flood year, 12 months, fountains of the Great Deep, 3.24 by 10 to the 27 joules. First 5 months, 150 days for the fountains of the Great Deep. The fountains of the Great Deep shut off after 150 days, according to Scripture. Volcanic heat, again, 10 to the 28th power. Entire flood year, 12 months. And of course, it will the volcanic eruptions will continue post flood, just not quite as intense or as extreme. All right, let's talk about convection rate during the GTF model. Okay, in step one, I did a test on this and everything, run a total heat input. Let's sum them up. And some of this is due to copy and paste from ChatGPT, so it might be a little bit gibberishly, but the math actually did work out that way, and difference, delta, and that sort of thing. Let's show you what the results were. Um, it's a major superheating of the system. Okay. Recalculating the Rayleigh number. The Rayleigh number is referring, or Rayleigh, I think it's Rayleigh number, is actually the number that you know how fast or the speed that mantle convection will make when you heat it up. The hotter it is, the faster it travels. And so it's, like I said, this is squarely within the realm of modern physics. In the catastrophic mantle overturn, the effective viscosity would have dropped drastically, maybe down to 10 raised 18 PAs, I think that's pascals, or even 10 raised 17. Let's assume a temporarily weakened mantle, viscosity about 10 raised 18 PAs, or PAs, I think that's. Okay, I'm going to calculate it. Now plug in all the Rayleigh numbers. It plugs in the numbers. Calculate numerator. And it goes further. It says results Rayleigh number equals 9 times 1089, and way above critical, huge convection potential. Okay, so rough speed estimate from standard convection scaling, and it gives the math here, and calculates the Rayleigh number in order to determine how much it would be. It says that's nearly 10,000 kilometers per year convection speed. Obviously, local flow speeds may vary, but that's the ballpark. Okay, and so now you got the value 1.825 times 10,301. So I think it's like 10,301.825 times 10 raised third power here, and it says 380 degrees Celsius. And you're talking about, this is all talking about the heat and stuff like that that's generated in convection, the quantity, the total heat, the delta T across mantle, Rayleigh number, and convection speed. Okay, and then it says 1,717,500,000 times faster than normal. New convection speed about 1.7 billion times faster than modern mantle convection speed. I know that sounds like it's impossible, but it's not. It's according to the laws of physics. The mantle convection can actually increase that fast if that much heat is applied. The laws of physics allow for mantle convection speeds to be that high when cataclysmic heat is involved at an unprecedented level, as what would have been the case during the global flood. this would have increased convection speed so fast that it would have bypassed conduction and pull heat from the crust, straight from the crust, at an incredible rate that would have been unheard of in present conditions. Okay, this shows the mantle convection as it speeds up as a result of heat. Notice how its cooling mechanisms, the cooling mechanism of the GTL model, is following this line right here as it actually is cooling up. Notice it gets to its peak. This is where the heat is the strongest, and this is where the cooling mechanism is the strongest. And then it gets down and gets weaker and weaker and weaker and weaker as it's tapering off. And that's also what's happening with the convection speed. It's going faster and faster because the more heat that's being generated, the faster it gets. It gets here, it gets to its peak, then the cooling mechanisms are taking over to cool it off, and it just kind of cools off right here. So this right here is really, really good at seeing the effectiveness of the model over time, the effects of the cooling mechanism, and how fast it's actually traveling, because it's traveling based on the amount of heat. So the fastest point of the convection speed be right here. That's when it's probably moving at the 1.7 billion times faster than normal rate. Okay, now let's talk some more numbers. Math alleviated within the flood year due to the GTL's model cooling mechanisms. Heat source and the accelerated nuclear decay and we know how much that is, and the heat remaining after the flood. And I actually did this calculation individually per heat source. It's 4.87 times 10 to 27 power joules. Meter impacts 4.47 times 10 to 26, and its leftover heat is like 7.264 times 10 to 18. And then we can go down the line, but the total amount that gets left over to the flood is 7.3186 times 10 to 27 joules. That's left over following the flood. Okay, total heat alleviation in percentages. 99.8709% of the heat is alleviated by the end of the flood year, and only 0.1291% of the heat remaining after the flood year. This is less than 1% of the heat remaining post-flood. Okay, now we're going to look at the heat being alleviated post-flood. Again, all of this is leftover heat, and it gives an estimated time of how long for that amount of heat to be alleviated. 5 to 7 years, 2 to 4 years, 4 to 5 years, 2 to 4 years, 3 to 5 years, but the total is 5 to 10 years following the flood. Remember, this is the amount that's left over from the flood. And following the flood, about 5 to 10 years later, all the heat should be alleviated. Okay, now let's anticipate some critics' responses that I want to deal with, just to kind of clear the air on some things that I think that they might be trying to argue against with my model. Okay, these are a series of anticipated criticisms I had anticipated throughout the time I've been working on, researching, and formulating my model. None of these hold a candle to my model, but as a Christian apologist who deals with critics and criticism on a regular basis, I felt it interesting, fun, and satisfying to see how strong my arguments are here and whether or not these criticisms could affect my model any. However, as a disclaimer, these may not represent exhaustively all the possible objections I had anticipated throughout the course of the many months I spent formulating this and strengthening my model. After all, I'll always be my biggest critic, since I play quote unquote devil's advocate with myself to assure the strength of this model against the most vicious of attacks. However, these do represent the most common ones that I had anticipated. Some represent the ones I fear these critics would make. In my opinion, most critics are predictable. However, every now and then, one of the critics will surprise me with a response or argument I had never heard before, or even challenge me with such an argument. It doesn't happen very often, but occasionally it does. So I've learned not to speak so universally about my critics. However, with that said, I thought it would be a good idea if I anticipated possible attacks against my model to test the strength of my model. What follows is a series of possible and commonly anticipated objections in time. We'll see if I'm right or not. I will also add a few possible criticisms to my RIFL theory as well. The way I am doing this is by using quote unquote objection as the critics claim or possible anticipated attack or action, while using quote unquote response as my given response. Of course, as time goes on, some of these responses could be revised, altered, or added onto. In my opinion, this is the most powerful model ever devised toward resolving the so-called heat problem. It is my silver bullet argument which takes down the entire heat problem with one shot. It is the most effective model out there. I can't wait to see how critics do actually respond to it. Okay, here's the first objection. Just add more heat. We already talked about this. My model is set up on a dynamic positive feedback loop, which is thermally driven and which increases proportionate to the amount of heat that's being introduced into the system. Although this has been the default response of critics, such as Erica from Guts and Given on YouTube, it will not work with my model. Positive feedback loops amplify effects, and one that is linked so closely to the amount of heat that's being introduced into the system will only increase my model's strength and effectiveness. Instead of making my model weaker, the critic will only make it stronger and even more effective than it already is by trying to add more heat or heat sources to the mix. Adding more heat will not be the go-to response that critics think that it is, not with my model. At most, this may affect how much heat is left over post-flood and the length of time it takes to safely mitigate that heat over time following the global flood. However, it will always come down to the same thing mechanically and mathematically. Most of the heat, probably about 90% to 99%, more likely 99%, will be alleviated during the flood year, while the rest of the heat post-flood would be safely mitigated over time. In previous tests, I gave it up to a few hundred years to allow for human error and to be as generous to the critics as I possibly can be. However, in my last test, and which is the one displayed in my video here, I aimed for precision, while the other test, although accurate, I wasn't aiming for precision because my focus was on the mechanics of the model, since it really wouldn't matter what values you plugged into the math. It'll always come out the same. Nevertheless, in this last test, I aim for precision and do feel that 5 to 10 years post-flood, or somewhere close to it, is far more representative of the reality than the previous test I ran. In previous test, I was just concerned with seeing how effective my model was against the critics' attacks themselves, rather than concerning with pinpoint accuracy. In other words, I was concerned or focused on the mechanics of my model. Rather than that. In other words, I was more willing to take the higher numbers post-flood if it satisfies the critics toward the effectiveness of my model. However, in reality, I don't think it would take all that long post-flood to alleviate the heat safely over time. All right, here's the next objection. This is physically impossible, or it's physically impossible to alleviate that much heat in 1 year. This would only be the case, this is an argument for incredulity, by the way, this would only be the case if we were dealing with asymmetrical model. In an asymmetrical model, the heat load is placed in a single component or mechanism, or even several components and mechanisms, but all disconnected from one another. In a situation like that, you will always reach a physical limitation of those components or mechanisms, even if you were trying to combine them. However, in a symmetrical model or approach, like the positive feedback loop, the components work in concert with each other, and the components and mechanisms, so the heat load isn't being individually weighed on any one specific component or mechanism. And each component and mechanism are working together and are amplifying each other as more heat is added to mitigate it over time. Additionally, my specific type of positive feedback loop amplifies or increases the effects proportionate to the amount of heat being introduced, increasing each component and mechanism accordingly. This positive feedback loop is thermally driven. More heat would only make it even more stronger and more effective than it is already. Each component scales according to the amount of heat being introduced, and each component mechanism scales according to the other components and mechanisms. Think back on my straight line and circle analogies. Coming up with an asymmetrical approach is like walking on a straight line. No matter how long the line is, logically, you'll eventually reach the end of the line, rope, or whatever it might be. However, if you walk in a circle, logically, you'll never reach the end of that circle. The later example matches a symmetrical approach. Since these components slash mechanisms work with each other, scaling upwards in response to more heat and to each other, in response to each other, none of them would ever reach their physical limitations. Since we know positive feedback loops of this nature exist, it's not physically impossible to happen, nor is it physically impossible to alleviate that much heat in a year. Under extreme and global conditions of the flood, a positive feedback loop of this nature would be more probable. It would not only be more than probable, it would actually be certain. Next objection. This would create a runaway effect. False. To create a runaway effect, the heat sources would need to be exponential, and they're not. They're all limited heat sources, even accelerated nuclear decay, both according to my GTF model and RIFL theory, the CPT, and even according to the heat problem argument itself. These are limited sources of heat, so it wouldn't create a runaway effect here. The closest may be my rifle theory to accelerated nuclear decay, but even that heat source is limited. As the volcanic eruptions die down, the positive feedback loop in the accelerated nuclear decay weakens until it tapers off at the end of the flood year, according to my rifle theory. You have misunderstood positive feedback loops. I imagine someone's going to try to argue that. No, I didn't. Positive feedback loops amplify each component in it as the results are fed back into the system over and over. My model is a specific kind of positive feedback loop, which is thermally driven and dynamically linked closely with the heat and the other component in the model. Positive feedback loops always create a greater increase as the results are fed back into the system. I have tested this across several AI programs, and they all agree on this. If you increase the heat during the flood by 10%, then convection currents would increase their effectiveness and speed by 10%. 10% more heat would be dispelled by volcanic activity. 10% more heat that is either ejected into the atmosphere or into the water, or both, depending on what stage of flood we're on. The waters would heat up 10% more heat. They will evaporate 10% faster. They would remove 10% more heat, latent heat from the waters. There would be 10% increase in cloud covering, which would also increase 10% faster due to the faster evaporation, 10% more rainfall, 10% more ash and aerosols would be thrown into the atmosphere, 10% increase in albedo effect due to volcanic cooling and cloud covering, etc. This is the critic's objection. Then the critic themselves, ironically, has misunderstood the nature of a positive feedback loop, not me. Objection, this is just silly. This is just a dismissal without justification. This isn't even a counter response nor argument that counters anything I've said in the model, and so this dismissal should be dismissed just as easily. If the critic won't seriously deal with the physics, reality, and arguments in what I am saying here, then I won't seriously deal with such a blatant dismissal without justification. Their objection is just arbitrary, possessing no justification. It's just their uneducated opinion on the matter, nothing more and nothing less. Objection. I don't believe you can get rid of that much heat. There's just too much of it. This is an argument from incredulity, which is a logical fallacy. This is not, and the reason it's a logical fallacy, by the way, is because truth is not dependent upon your sensibility of what it sounds true or not to you. That's not how truth works. Truth is truth, no matter whether it sounds plausible to you or not. It makes no sense. The point is that it's still true. It can still be true, because it's not based on your sensibilities. This is not an anticipated objection per se, since a critic has already passed this to me when I was talking to him about my model. This particular critic is known on my channel for making this particular logical fallacy of arguing from incredulity, so much so that he even admits this as an apt description of his thoughts on the matter. The reason this is a fallacy in logic is that truth, right, and wrong are not subject to your sensibilities of what you think is right or wrong, or what sounds right or what sounds wrong to you. Truth is independent of these kinds of sensibilities and your personal thoughts on the matter. Yes, it's hard for people to grasp because there's a lot of heat. And I admit there's a lot of heat involved during the flood. But if there was something that can be regulate, mitigate, and alleviate significant portions of the heat over time, then it would be possible. We have that with the conditions of the flood. The Earth's heat budget is an impossible number to grasp, but being incredibly high doesn't in itself make it impossible. Also, the reality, really the issue behind the so-called heat problem isn't just the amount of heat, but the speed in which the heat is removed. My model moves the heat from the crust and mantle at accelerated speeds via volcanic eruptions. This heat is removed from the water via latent heat removal, via rapid evaporation, and significant portions in the atmosphere radiates into space as infrared radiation. I challenge your math. The funny thing is, I'm bad at math, but so far, every math argument I've used since the Tompkins controversy hasn't been challenged yet. So I'm still waiting for the critic to try to challenge my math somewhere. So far, they haven't done it, which I would think that they would have done it by now, because I'm not. It's like I put over here. There's no secret that I'm not good at math. And I've even publicly admitted this fact on my channel. However, I am not ignorant of my own abilities nor limitations. So for my math, I sought out AI programs and other computational devices like converters. Although when I really got down to the test, I did use AI programs to calculate the math. I never did the math myself. However, this would be inconsistent of the critics, because most of the critics get their numbers from Erica from Guts and Gibbon, who in turn got it from some of her math friends. So or either that or online. So it would actually be kind of weird that I've had critics quote Erica's numbers to me and then sit there and say, oh, well, you can't use AI programs to calculate math. Yes, I can. It's a tool like anything else, and I'm not good at math, so I'm going to rely on computational methods to figure out the math. The way I see it, if Erica can trust her friends on the math in her figures than she used in her video on this, then I am allowed to trust the AI programs on mine. Furthermore, even if the values were wrong, estimations were off, or you decide to add more heat to the math because of the mechanics of the model, this positive feedback loop would only, because of the mechanics of the model, this positive feedback loop would only increase in strength and effectiveness with the prospect of higher numbers. Critics challenging my math produces a futile result, since even if my math was wrong, my model would still work. Objection. The cloud covering would add more heat, or the volcanic heat would overpower the volcanic cooling mechanism. This was also not exactly an anticipated objection per se, since that same aforementioned critic had responded to my reference to cloud covering. Even if it produced any heat at all, it'll be negligible. And I found this out too whenever he brought it up. It's a very small amount of heat that would produce. It tends to be more likely a cooling effect than a heating effect. It actually, because of increases the albedo effect. Since it blocks the sun's heat, reflecting its rays back into space, it causes a cooling effect due to the increasing of the albedo effect. This is a universal trend with cloud covering, which is why it always experiences a significantly cooling effect on a cloudy day, while we experience a significant heat from the sun on a cloudless day. Any residual heat from cloud covering will be insignificant compared with this. The same is true on volcanic eruptions. Although these eruptions distribute powerful explosions of heat, they do not overpower the cooling effect, which is always also the universal trend with volcanic cooling, which is why we don't experience warming effects with these volcanic eruptions. Whenever we experience volcanic eruptions, we have a cooling effect that occurs around the area, and even in some cases global, because like a super volcano could affect the global temperature and global climate and things like that as a result of volcanic eruptions. Objection: I'll challenge the mechanics of your model and your math by increasing the heat. Strawman argument and misrepresentation of positive feedback loops. One of the things I am afraid is going to happen is that upon a critic's challenging my math or trying to quote unquote prove me wrong, the critic will increase the heat without increasing the rest of the components of the mechanism in the model. If they do that, they can use the heat to overwhelm the system. However, in doing so, they've dishonestly misrepresented both my model and with my positive feedback loops, which always amplifies the results. And my particular model had demonstrated a specific kind of positive feedback loop dynamically connected with the heat, and thus, in other words, because it's thermally driven, and the other components in the model. So not only does it increase with the increasing heat, but it does so proportionately. Objection. Okay, then I'll increase the heat component in the model, but I'll only amplify them by a little bit, say 3%, since that's all I have to do to properly represent positive feedback loops, and then amplify the heat by 20%. Although the critic represents positive feedback loops, because all you need to be a positive feedback loop is to amplify the results to some degree, they've dishonestly misrepresented my model and arguments, strawman argument, actually intentional strawman argument, as well as misrepresented the type of positive feedback loop that's presented during the flood using these conditions of the flood account. This is dishonest, especially since I've called this attack early on and called the critics out on it before they could respond this way. In order to be a true parallel where your math is on par with every proper, accurate, and true representations of my model's arguments, positive feedback loops in general, and my specific type of positive feedback loop, you need to increase everything proportionate with the heat. That means everything in the model, it has to increase proportionately to the heat. You can't increase the cooling mechanism by 3% and then increase the heat by 20%, just so you can have an overwhelming effect on my model. Everything has to increase proportionate to the amount of heat that's being introduced. If you do it the right way, mathematically, most of the heat, regardless of what value it is, would be alleviated by the end of the flood year, and with some of the heat remaining following the global flood, and is safely mitigated over time by a much weakened positive feedback loop and the same processes, components, and mechanisms mentioned in my model, talking about the cooling mechanisms. It's repeatable, and it seems to work at every single time. However, you must honestly represent it while doing the math. If you don't, you'll overwhelm the system. But if you do that, then it's meaningless since it doesn't reflect the reality of my model. This is a dishonest tactic, but I am expecting such as a maneuver. Thus, it's doubtful if if I'd be surprised by such an attempt if they did do that. There's no evidence for it. It's speculative or it's ad hoc. This is false. In this video, I had to present example after example of positive feedback loops involving volcanic eruptions, both historical and modern day examples. I showed the effects of the biblical account of the flood conditions would have on the earth, the processes, components, and mechanisms involved in this model. I missed the L there. The model are not theoretical, but based upon well-established physics. We know how these processes work. In a positive feedback loop, they would significantly cool the planet while successfully expelling a significant amount of heat via volcanic eruptions on a global scale from the mantle and the crust of the earth. This is not speculation. We know this. The GTF model is built on documented thermodynamic principles, real-world geophysical observations, and engineering analogs. It's no more speculative than climate models or geothermal cooling systems used in engineering. I am also doing and calling for simulations and testing showing scientific humility and commitment to empirical verification. The problem is people assuming that this diffusion would happen very slowly because in today's rates it would diffuse slowly, but the extreme conditions of the flood would have expelled the heat via accelerated convection currents like jets in a jacuzzi, only much, much faster than that. It's also not ad hoc either. This is where someone postulates a story because the evidence doesn't support their view. However, in this case, we have evidence that supports their views, or my view, or our views here. We have evidence that these things like accelerated nuclear decay, the CPT, the fountains of the great deep, heavy volcanic eruptions during the global flood, etc. And we even have evidence that the Earth's crust was never that hot. Fission tracks and polonium halos, because those would have been destroyed if the crust of the Earth was ever that hot. We also have evidence for a global flood, the biblical account, flood stories all over the world, most of which are global, evidence from fossils, evidence from polystrate trees, evidence from mollusk shells found fossilized in the closed position, etc. Nothing about this is ad hoc. In fact, to be ad hoc, there cannot be evidence supporting it. But I gave you evidence of these kinds of positive feedback loops and can give more if asked upon me to do so. However, there has to be a point where we realize it's not the evidence of my examples, not the evidence of my examples that's the problem, but the critics' lack of willingness to believe what I am saying. There is nearly and seemingly endless stream of examples of these kinds of positive feedback loops, and I do not wish to spend the rest of my life trying to give them to a critic that refuses to accept it no matter how many examples I carry. At that point, I'll realize that the problem is with the critic, not with my examples. There's lots of evidence in favor of this kind of positive feedback loop and matching these conditions. All I can do is provide the evidence, but it's up to the critic to accept them or not accept them. Okay, objection. Volcanic heat would add more heat to the flood. It's true that volcanic heat would add more heat to the flood, which was mathematically calculated in, if you remember correctly. But the volcanic stability is based upon the tectonic conditions and all of the heat sources being generated. But most of these ceased by 150 days into the flood. This would have weakened the loop as time went on. The volcanic eruptions became less frequent and less powerful and probably more sporadic. This feedback loop would have weakened over time, and even although still active, would continue following the flood at a definitely significantly weakened state, and definitely far more localized than before. Over time, the heat from volcanic activity would have lessened until the global volcanism ceased completely and ending the positive feedback loop. Objection. These cooling mechanisms can't cool down the planet from that much heat. partially false. Individually, they couldn't. If taken asymmetrically, then each component would not be enough to take down the heat problem. But taken symmetrically in a positive feedback loop where everything is scaled upwards, constantly increasing, and working together in concert with each other, and with no reachable physical limitations like that, then they could alleviate the heat problem. The issue is that you keep thinking in asymmetrical terms rather than in symmetrical ones. Objection: it's still too much heat. No more heat than the heat budget is a lot of heat. Yes, there is an insane amount of heat involved. Even less than 1% of this heat post flood seems like a lot. However, it's no more than what the Earth is used to receiving from the sun. The real issue isn't the amount of heat as much as the speed of getting that much heat out of the Earth before cataclysmic results happen. And this is what my GTF model does. It's effective and rapidly demonstrates the removal of this heat from the Earth while cooling mechanisms cools the planet down effectively within the flood year using the conditions of the global flood according to the biblical account of the flood, and does this successfully. Objection: if this is true, why hasn't anyone else thought of this? Because no one else has thought of something before doesn't change its validity. A lot of the reason is just because people are used to thinking asymmetrically rather than symmetrically. They're looking for that one solution that would work. Sometimes it's because they are not thinking outside the box. They are looking for solutions and mechanisms no one else has considered. They may not be aware of these kinds of positive feedback loops are already observable in volcanic eruptions and the sheer act of using volcanic eruptions on a global scale, which is present in all flood models, including the CPT, hasn't occurred to most people yet. Other times they are stuck in a specific solution like miracles that either they proposed or that has been proposed without looking into the actual present day and observed phenomena like that. Objection: the RIFL theory would make accelerated nuclear decay exponentially. False. This is because upon the positive feedback loop that is initiated via ionization, which happens via volcanic eruption, supplying the necessary energy and radiation to cause ionization. Once this energy weakens, so does the positive feedback loop. Objection: what about heat and pressure effects with the RIFL theory? Response: it's true that even with ionization ceasing, you still have the heat and pressure continuing accelerating nuclear decay. But if you look at the experiments that were done, the less heat and pressure that was produced, the less acceleration. Ionization in these experiments always provided the greatest acceleration. So with the heat and pressure from volcanism weakening as well, and no more ionization occurring, the positive feedback loop would weaken significantly until, talking about the positive feedback loop of the accelerated nuclear decay, the RIFL theory, weaken significantly until the heat and pressure being produced via and would also diminish and eventually cease completely. These results would never continue exponentially. Objection: concerning the RIFL theory, these conditions don't occur naturally. This one gets brought up to me a lot on accelerated nuclear decay. This is actually a common argument by one of my critics on my channel, and I think Erica uses it in her video as well, and it's false. Ionization is not only seen in ionizing the air via lightning bolts, I mentioned it earlier, but it's also seen with volcanic activity. We've observed ionization, heat, and pressure in lab experiments altering decay rates, so we know this can happen. What he might mean, if he would word it appropriately, is that we don't usually observe accelerated nuclear decay in nature. This is because it would take a lot of heat and pressure, and I would even throw in energy there for ionization, that is not normally generated at one given time in our present world. Ionization takes a lot of energy. However, during the flood, in a positive feedback loop initiated by global volcanism, these conditions would have been met and thus would have happened. His problem here is assuming that those conditions had never arose at any given time, which is circular. He must assume global flood, the biblical account of the flood, and all conditions that happened during the global flood are wrong or didn't happen from the start. This is a circular argument. He is also quite possibly thinking asymmetrically, like the amount of heat that's generated all at once with a star or with a sun. But if you think symmetrically with a positive feedback loop, then these conditions can be met without blowing up the planet. Objection. You created the RIFL theory to make the heat problem with accelerated nuclear decay more manageable. False. And the circumstantial ad hominem fallacy. Whatever my motives were are irrelevant to the truth of my proposal. Secondly, this is actually false. The fact that the heat is occurring in bursts rather than in a constant acceleration was an unforeseen side effect of the theory that worked to my advantage. But in truth, the RIFL theory was created first, although not called RIFL theory at that time, while I was still formulating my model on the heat problem. Back then, I hadn't even discovered what a feedback loop was, and it certainly hadn't been added to my model yet. But then I was calling my model to the heat problem, the heat absorption distribution. I can't talk right now. I was calling my heat problem, my model to the heat problem, the heat absorption and distribution, or HAD model, and my theory on accelerated nuclear decay, the feedback loop theory on accelerated nuclear decay. After I discovered the feedback loops or the Floop theory, because I was calling it affectionately the Floop theory originally. It was after I kept running into physical limitations with my HAD model and had discovered that mantle convections in geological events like volcanic eruptions are set up on a positive feedback loops, that I rebooted my model and then later changed the name of my theory on accelerated nuclear decay to the RIFL theory. It was only after my discovery with positive feedback loops and the fact that and is set up on a positive feedback loop that I realized the advantage of this theory on the heat problem. By the way, I created my theory on accelerated nuclear decay following a critic who had challenged me on what had triggered and in the first place. It had nothing to do with my heat problem model at that time, so the two was actually not connected with each other at that time. It's actually because of me pondering the idea of a quote-unquote chain reaction due to the fact that, and I actually was pondering that for a while now, that was before I actually discovered positive feedback loops. Fact that I found out that heat was a byproduct of nuclear decay over the past few years is now is how I stumbled onto feedback loops when I began researching that idea more closely. All right, we're going to quickly deal with miracles. I don't personally debate others on their solutions. I don't have a problem. I think that young Earth creationists eventually all get into the same spot eventually. The only thing, except for unconventional YECs, because unconventional YECs will take certain interpretations that evolutionists agree with and things like that. But most YECs will usually wind up in the same spot eventually, even if they might accept certain miracles or certain models to get them there. So I don't debate other YECs on their particular models that they prefer. But this one is kind of a popular idea, and it's one that gets thrown around a lot by critics, like, oh, well, you can invoke a miracle. So we're going to talk about that real quick, just very briefly. Again, I have no problem with people who invoke miracles. Baumgartner invoked a miracle. Mike Ord invoked a miracle. I respect both of these men very much, and I like a lot of their arguments on a lot of things. I think they're both very smart men. But I don't agree with that it's a miracle, and I'll give you the reasons why here in a minute. So what about miracles? As a Christian, I don't see there's anything wrong with invoking a miracle. Critics act as if that's a bad thing, but that's because they're naturalists who often engages in the concept called metaphysical naturalism, where you have to pretend, even if you believe in God, like God doesn't exist and acted in history and the natural world to do science and history. I reject this notion. you can still do good science and historical studies while invoking a miracle. However, with that said, I wouldn't postulate a miracle as a solution willy-nilly. Miracles, by their very nature, are not everyday occurrences, and without biblical nor experiential support, it would be hard to verify. I am open to miracles as a solution, but the real question isn't can miracles happen, but was it a miracle? Which is what I am asking here. I will give you several reasons why I think this wasn't a miracle. Okay, the first one is there's no biblical evidence of the heat being removed via divine intervention. This is key, although I wouldn't call it definitive, since that would be an argument from silence. But as stated below, or stated before, it would be hard to verify without it. Biblical evidence would actually help verify the existence of whether the miracle actually happened, that God actually intervened in some sort of miraculous sort of way. Again, I have no problem with miracles. I have no problem with people acting miracles. I have no problem if it was a miracle. The issue is, though, was it a miracle? And that's the issue at hand. And without biblical support, it's very difficult to try to argue that it's a miracle. People who believe this was a miracle often must give into speculation. Mike Ord, for example, in our interview together, said that he thought God was in charge of the heat, but this is speculation. Again, I love Mike Ord's stuff. I want him on my channel. I want him on my channel again. He's a great guy. He's a brilliant guy. But the point that I'm making is that often enough, the ones who invoke miracles in this situation will often have to give into speculation, because the Bible does not tell us that God intervened in getting rid of the heat or interacted in that way. Calling it a miracle without biblical support makes the person look as if they are only postulating it for the lack of a better explanation. Sometimes this is seen even in their arguments, because they will argue that the main reason that they are think it's a miracle is because they don't see no physical reason why how to make it possible otherwise. Baumgartner has said this. Mike Ord has said this. And so that's usually, and that does what it looks like. It looks like it's just because of a lack of a better explanation, or possibly committing the God of the gaps type fallacy. If they had at least some biblical support, then the critic's rejection of it would look like the critic is just engaging in circular reasoning and arbitrarily rejecting the biblical account. But without biblical support for it being a miracle, then the critic would be free to reject that idea on an evidential basis, apart from committing any circular arguments at that point, unless, of course, their arguments against miracles is that they don't believe that they happen, which then would be circular. Number 4, we have a physical explanation of how the heat could have been alleviated because of the positive feedback loop, or at least we do now by my GTF model. The biggest selling point of the whole miracle explanation is that we had no physical way to make that possible. But we now know that to be false. There is a physical way to make alleviating that much heat fast enough is possible via a positive feedback loop. Though a positive feedback loop, these components would never reach through a positive feedback loop, these components would never reach their physical limitations. So if there exists a physical way to alleviate the heat, especially since this is through the conditions of the flood, which are already in place, then there's no reason for God to perform a miracle. A miracle would be more feasible if a natural solution isn't present nor presentable. All right, my conclusions. This is my conclusion. The geothermal feedback model, or the GTF model, argues symmetrically for a positive feedback loop that scales or increases upwards based upon the amount of heat that's being introduced into the system. The GTF model offers mantle convections, volcanic activity on a global scale, the high specific heat capacity of water to absorb tremendous amount of heat, rapid evaporation, latent heat removal via rapid evaporation, cloud covering, volcanic cooling, and albedo effects via cloud covering and volcanic cooling. The combination of these leads to a symmetrical approach of a positive feedback loop that never reaches their physical limitations, since these components in a loop are working together in concert with each other. The heat is expelled through volcanic activity, volcanic eruptions on a global scale. The positive feedback loop alleviates most of the heat within the flood year, while the remaining heat is mitigated over time post-flood. My RIFL theory, which has set up the first naturalistic trigger to accelerate nuclear decay, and which sets and on a positive feedback loop itself, makes the heat load during the global flood more manageable by occurring in bursts of acceleration and thus bursts of heat instead of a constant acceleration of nuclear decay. The GTF model is my silver bullet model and argument because it shoots every heat source down. This model resolves all of the heat problem, not just a specific source of heat. This resolves the entire heat problem. Several tests via various AI programs like ChatGPT, PoAI, Liner, and Google AI has been done successfully since the GTF model was fully formulated. Several mathematical modeling had been done on the GTF model. The last test was the most precise test ever done, in which this model showed over 99% of the heat was alleviated during the flood year, as much less than 1% of the heat remained post-flood. The remaining heat was also shown to have safely mitigated over time in an estimated 5 to 10 years, although in a previous test, my model was willing to advocate the possibility of the heat being fully mitigated post-flood up to 200 years following the end of the global flood. This last test represents the more realistic estimates, while the 200 years was me trying to push the numbers up as far as I could go with them and be as generous with the critics as possible. The GTF model had successfully resolved the so-called heat problem, did so without invoking a miracle, and is now the most powerful and most effective model out there to resolve the heat problem. By using the natural conditions of the global flood enacted originally and ultimately by God, the GTF model was able to successfully resolve the so-called heat problem. So the critics will have to find something else to try to get us on. The heat problem has been officially resolved. The heat problem is dead. So, I know this has been a long video, longer than my last one for sure. But I knew this was going to be a long video when I first made the presentation. I think that a lot of people are treating the heat problem like they did distant starlight a while back. A while back, distant starlight was a thing. It was the bombshell response to young Earth creation and position. And so now that we know how light got here, and light can get here in a biblical time frame, we know that it's just a matter of how you're measuring time. We got relativity and that sort of thing. And so now that we know how all that works, the distant starlight problem isn't really a problem at all. And most young Earth creationists know that now. And so it's not as popular. Sometimes critics will still bring it up, but it usually shows that they're ignorant on relativity and that sort of thing. With the heat problem, it's like their new bee's knees, right? It's the argument that is now being brought up a lot, especially online. So it was just a matter of time. Someone comes up with a mechanism for a model that actually shows how these conditions during the flood would alleviate the heat. Every heat source alleviated as a result of these flood conditions. And so that's what my model does. And right now, as far as I can tell, it's the most powerful model out there. Now, some people might say, wait a minute, what about miracles? God is very powerful. He said, yes, I know. But miracles aren't a model. Miracles aren't considered models. I don't think any Christian would actually call a miracle a model. They'll call it a miracle, but they're not going to call it a model. It's a solution, but it's not a model. So this is not saying that it's more powerful than miracles, but it does give a more reasonable conclusion because we don't have any evidence that God performed a miracle during the global flood to get rid of the heat. There is no biblical support for that, and so that is lacking. Now, I don't have a problem with people who invoke miracles. I love you guys. I know lots of people that invoke miracles. I think Sam from Redefine Living does. I know Baumgartner does. I've had him on my channel. I wouldn't mind having him back. I would like to have him back. Also, Mike Ward. I do plan on inviting Mike Ward back. I love Mike Ward's stuff. He's one of my favorite young Earth creationists. My favorite young Earth creationist is Dr. Jason Lau, but Mike Ward is one of them, one of my favorites. And I love Baumgartner stuff as well. And I like all these guys, but I just don't invoke. I don't think that I don't invoke a miracle unless I have reasons to justify invoking a miracle. If I had reasons to justify it, then I would in a heartbeat because there wouldn't be a problem with it. I don't think I don't have a problem with someone doing good science and invoking a miracle the way critics do. That's just the critics' metaphysical naturalism playing through. And I don't believe and agree with engaging in metaphysical naturalism. But anyway, thank you for watching Apologetics 101. And this has been a great video. Don't forget to subscribe to my channel if you're not. Don't forget to like the video, give it a thumbs up. That will help YouTube promote the video and get this information out to more people. And I want to popularize this model very much in the coming months and throughout in the coming years, on my channel and on my website. I want to be able to get this model out there to more people. So I'm hoping that other people will get a wind of this model. It is the most powerful model ever presented on the heat problem. So I'd love to see what y'all think of it. Okay, I know everybody has their own ideas of what happened, and I don't want to fight any other younger creationists on that. If you guys have your own views and y'all committed to those views and y'all think those views work or whatnot, that's okay. But I do think this works with the evidence the best. It works with the flood conditions the best. It's just my opinion, but it does work with the flood conditions the best. It does seem to alleviate all the heat. All the heat, the vast majority of it is alleviated before the end of the flood year. So you don't have to abandon models. You don't have to abandon things like accelerated nuclear decay or anything like that. It's not necessary to abandon these things. This model is very powerful. It's thermally driven and it alleviates the heat. The vast majority of it is gone before the end of the flood year, and the rest is mitigated safely over time following the flood, more than likely within a few years or so. And so this is a very good model. I really love it. I will popularize it as time goes on. If you're new to my channel, I do videos on responses. I do interviews on here a lot. Actually, I've got an interview next week to do a debate review of the debate between Dr. Jerry Bergman and Erica from Guts and Gibbon, and that happened on Standing for Truth. And I'm going to have Dr. Jerry Bergman in here as well as Dr. Peter Line, and we're going to have a good time responding to Erica's arguments during her opening case in Standing for Truth. So let's go ahead and close this video out. And again, glad to have y'all with me. Thanks for being here. I appreciate it so much. Drop a comment below. Let me know what you think, and God bless.